Okay, so these are the notes for measures of central tendency and dispersion. How do you find measures of central tendency and standard deviation? Make sure you write that essential question down. All right, so first main idea is measures of central tendency. And we've gone through some of this stuff when we were reviewing for the EOC, but this will be on your final as well. All right, so some things that I've typed in for you already. You have statistics, which are numerical values used to summarize and compare sets of data. Measure of central tendency, a statistic used to represent the center or middle of a set of data values. And so those that we've talked about are mean, median, and mode. These are all measures of central tendency. Remember mean or average, or in your calculator, it had the X with the bar above it. When you add all the numbers in the data and divide by how many numbers there are. Median, put all the numbers in order, then find the middle number. Remember, if there were two middle numbers, you find the average of those two. And then mode is the number that shows up the most. It has to show up at least twice. So if no numbers repeat, they're all different numbers, then there would be no mode. If there was more than one value that showed up the same amount of times as another and it was the most, then there could be more than one mode. All right, so let's just review how to do this in your calculator. Otherwise, if you don't have a graphing calculator, you would have to do all of these by hand. So for mean, you'd have to add all these numbers up in your calculator and divide by 10, because that's how many there are. And for median, you have to put them in order, find the middle number, and mode is pretty self-explanatory there. All right, so remember, this is where you go to stat, we edit. We're going to edit list 1. So to clear your list, you highlight list 1, hit clear, and then enter. Type them in. So 4, 8, 12, 15, 3, 2, 6, 9, 8, and 7. Okay. Then you hit stat again, calculate, and then pick one variable statistics. And then you may have to hit enter a couple more times, and then it gives you this information. Okay, remember the X bar is your mean. So then my mean equals 7.4. So that's what you get when you add them all up and divide by how many there are. The median, so they went ahead and put them in order for you because I just typed them in the order that I saw them here. So the calculator puts that in the order for you. So median here is 7.5. Now your calculator might tell you the mode. I know the Casios might tell you the mode, but here we can just look. So 8 shows up twice, and that's the only number that shows up 2 or more times. So 8 is my mode. And these are usually pretty close to each other because we're measuring that central tendency. So it tends to be in between 7.4 to 8 there. So they're all close. Okay. All right. So then on the back of your note sheet, go ahead and put dispersion is going to be your second main idea, your last main idea for these notes. And so I put some things in there for you. So measure of dispersion is a statistic that tells you how dispersed or spread out data values are. And what we're going to talk about that does that is range and standard deviation. We did talk about range before, but not standard deviation. Remember, the range is the difference between the greatest and the least data values. So you take your maximum number minus your minimum number. Standard deviation is the typical difference or deviation between a data value, between data values and the mean. So we use sigma. This little circle with a little tail here is called sigma. And this is the equation that you do. So basically you take each x value in the set and subtract it from the mean. So that gives you a difference what that number is from the mean, and then you square it, and then you plus the next number in the data minus the mean, square it until you've done that with all the values divided by n, and we square root that. So those of you that don't have a graphing calculator, because the graphing calculator actually tells you this, you will have to do this by hand to get it, okay? And n is the number of values, okay? All right, so that tells standard deviation and range give you your dispersion, or how spread out the data is. Okay, so let's go back to the same data set that we had, but now we're going to do range and standard deviation of that. So if you go back to your calculator, we still have all of that information in there. And notice they give you this little sigma x. That is your standard deviation. Okay, so right here, 3.8 is our standard deviation. So sigma, which is standard deviation, we'll just write SD for standard deviation, is 3.8. So again, sigma is your standard deviation. Then for the range, it tells me my maximum value of x and my minimum value of x. So I'm going to do 15 minus 2, which is 13. So the range is 13. Now, those of you without the graphing calculator, here is what you would have needed to do. You would have done the square root, long square root. And remember, our mean from earlier was 7.4. So you would do, in parentheses, this first 0.4 minus the mean, 7.4, and square it. Plus the next number, 8 minus 7.4, the mean, squared. Plus the next number, 12 minus 7.4, in parentheses, squared. Plus the next number, 15 minus 7.4, in parentheses, squared. Plus the next number, 3 minus 7.4, squared. Plus, and you would do that with all of these numbers until you got to the last one in the set, which is 7 minus 7.4, in parentheses, squared, all divided by n, which is how many there were. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. And then type all that in, square root of all of that divided by 10, and that would give you 3.8. That's doing it by hand. Okay. Otherwise, your calculator does it for you, and it's this number here with the little sigma sign. Okay. So that tells you how dispersed there are. So each number is standard deviation about 3.8 from each other, and the range of values that we're covering is 13. So that tells you dispersion, how much you're dispersed or spread out. Values are dispersed or spread out. All right, then you have a definition there, outlier. It's a value that's much greater or much less than most of the other values in a data set. Okay, so here we don't really have any outliers. These are all pretty close to each other. But let's say on example 3 that an 11th student has to wait 30 minutes for the bus. Okay, so now we have all those original values. We had the 4, the 8, 12, 15, 3, 2, 6, 9, 8, 7, and then we add an 11th student who had to wait 30 minutes. So 30 is much further from these other ones. So 30 is the outlier of this data, because it's much greater than the rest of the values. Okay. All right, so part A says find the new mean, median, mode, range, and standard deviations. So all you have to do is go back to your graphing calculator, hit stat, edit, and then just go to the bottom of your list and add the number 30 to your list. Now we'll go to stat, calculate one variable statistics, just because there's one list that we care about. Okay, and then it gives us our new values. All right, so the mean is now 9.5 if we round it to 1 decimal place. So the mean is 9.5. The median, let's see, median is 8. The mode has not changed. Adding that number 30 didn't change our mode, so our mode is still 8. Range now, we're going to take our highest number 30 minus the minimum number 2, so 30 minus 2 is 28. So our range is much more, and then standard deviation is that sigma number right here, which is 7.4. So it changed some things quite a bit, some more than others. So then part B asks, which measure of central tendency does the outlier affect the most and the least? So the measures of central tendency is just mean, median, and mode. So what did it mess with the most? Yeah, the mean. So the mean was most affected. Okay, and then which one was the least affected? Right, the mode. It didn't change at all because adding that number didn't make any repeat numbers because it's the outlier. Okay, and then part C says, what effect does the outlier have on range and standard deviation? So our range and standard deviation before, standard deviation was 3.8 and the range was 13. Well, now the standard deviation is 7.4. So it went up almost 4 whole points, and the range is now 28 from 13. So, so it makes the range and standard deviation much larger. Even if your outlier was a much smaller number than these, it would still make your range and your standard deviation larger because it's more dispersed. You got much higher number or a much lower number, whichever your outlier is, it's still going to make the range bigger and the standard deviation will be larger as well. Okay. All right, and so that's the notes for measures of central tendency and dispersion, a lot of review, and then we added this dispersion piece in here with standard deviation. Okay, so go ahead and do repetitions and get yourself ready for your final.